with your solar ambitions. Today I'm going to be talking about how to properly size your solar system. So how much solar do you need? Well, what I'm about to tell you is the most important thing you need to remember when designing any solar system. Every component you buy and every decision you make regarding your solar system revolves around the idea of knowing how much power you need to power the appliances that you want. For example, the size of your solar array, aka the number of solar panels that you need, solely depends on how much energy you use on a daily basis. The size of your battery bank depends on how many days you want your energy storage to last you through cloudy days. The charge controller you need needs to properly manage the energy between your solar panels and your battery banks, and the inverter you need depends on what appliances you want to run off your system. Even the sizes of wires and fuses depends on how much energy is going to be flowing through them. So you may be asking yourself, how do I size my system? How do I know how to calculate all this stuff? Well, I'm going to go ahead and tell you right now. The first thing you need to do is you need to list out every appliance that you intend to run off your solar system. I know this might sound tedious, but you need to go around to every appliance and find what's called the power consumption rating label. This is a label that could either be imprinted on the device or charger itself, or it's printed on a label that is stuck to the device or charger. What you're going to want to be looking for is the output rating for the device. Now, this can either be listed as watts or volts and amps or milliamps. Ultimately, what you're going to be looking for is the wattage of the device. If it already says it on the label, go ahead and write that number down. But if you're left with volts and amps, I'm going to give you an easy equation to use so you can convert those into your output wattage. The equation is watts equals volts times amps. And if you have milliamps as your variable, all you're going to need to do is take that number and divide that by 1,000. So if you have 500 milliamps, divide that by 1,000, that will give you 0.5 amps. If for some reason you can't locate the power consumption rating label, try to find the model number of your device and either Google search it or just find something that's similar to it online so that you can get an idea of how much power that will draw. Once you list out every appliance that you intend to use with your solar power system, along with the corresponding output wattage, what you're going to want to do is you're going to ask yourself with each appliance, how long are you going to use it each day? And for this number, you're going to use hours as your variable. So if you're going to use an appliance 2 hours a day, you're going to write down 2 in that space. If you're going to use an appliance 30 minutes, you're going to write down 0.5 hours. If you're going to use an appliance 15 minutes, write down 0.25 hours. I think you get the point. After you've written down all of the hours that you intend to use all of your appliances, what you're going to want to do is take the output wattage and multiply that by the hours per day that you intend to use each device. For example, let's take that 85-watt computer charger that we had earlier. We're going to take that 85 and multiply it by the 4 hours we intend to use it. And then since we have 2 of those chargers, we're going to multiply that by 2. So 85 times 4 times 2 is going to give you about 680 watt hours per day. You'll want to repeat this process for each appliance that you have on your list, and at the end of it all, each appliance should have a corresponding watt-hour figure. Now, with all of those watt-hour figures, you're going to want to add them up, and at the end of your list, you should have a figure that is the total number of watt-hours that you're going to be using on a daily basis with your solar system. Now that you have your total watts per hour that you intend to use on your system, what you're going to want to do is calculate your solar needs. And to do this, you can go in one of 2 directions. You could either go nerdy like I did and try to find the technical details and energy losses in the system, or you could use this really easy calculator online. And for the sake of ease, I'm going to use the online calculator, so I'm going to jump on the computer and show you guys exactly what you need to do. Okay guys, I'm here online taking you through a real-time walkthrough of how to properly size your solar system, and I'm here on the Alt-E store solar calculator. If you type in solar calculator onto the computer, onto Google, you will find a million calculators. The only reason I'm using this one is because it made the most sense to me. So when it comes to battery bank sizing, this website is actually going to calculate the size of your battery bank, your solar panels, and your charge controller. So it's going to do three separate things, but we're going to first start with the battery bank sizing. Now, when it comes to battery bank sizing, here in step 1, it says you need the total number of watt hours per day. Now, when it comes to that, we just calculated that number out, and if you recall from our previous spreadsheet, we had 2,030.55 total watt hours per day that we consumed. And that's going to take us now to step 2, and it's going to ask you how many days you want your solar system to run without sun. This is basically saying during cloudy days, how many days of storage do you want for your battery bank? And for our specific needs, we just decided to go ahead and do 2 days. This is on the low end because we travel around in an RV, and we can kind of compensate for the lack of sun by moving to different locations. But if you're in a stationary position with enough money and enough space to store all these batteries, you're probably going to want to do more like anywhere from 5 to 7 days of storage. But basically what I'm going to do is I'm going to type in 2 because that's for our system, it works best for us. Again, we're just showing you what works well for us. So now on to step 3, we're going to talk about the lowest amount of temperature that your batteries are exposed to. And for us, again, since we move around, we don't get into freezing temperatures that frequently, but worst case scenario, 30 degrees is going to be the lowest that our battery bank is going to see. And again, if you live in a warmer climate, you're going to be warmer. If you live in a colder climate, go ahead and put 20 degrees. This just gives them a good idea of how the batteries will be able to function in the temperatures that they're going to be exposed to. Now that you got that all entered in, it's got the results here, and you've got the total number of watt hours that you need for your battery. But for our specific circumstances, we're going to be focusing on this right here. It's the number of amp hours that you need for your battery bank, because in the solar battery category, they usually categorize everything in amp hours, not in watt hours. So for us, we need 1,090 amp hours of battery bank. Just keep in mind, this compensates for a 50% discharge rate of your batteries. Depending on the type of technology that you use for your batteries, most of them can only be discharged about 50% before you actually damage the batteries. I will go into a lot more of this in the future, but this calculator already compensates for that 50% discharge. So keep that in mind if you're using a newer technology like lithium ion, where you can get 80+% of usage out of the battery. Just keep that in mind, that the calculations are going to be off. Also, right here, you'll notice that it's 12, 24, or 48 volt systems. For our system, it's a small system, so we're going to keep it a 12 volt system. If you do have a larger system, you might be 24 or 48 volts. I will explain more of that in the future if you are going to be doing that, but for our circumstance, we're going to be keeping it at a 12 volt system. Okay, now that we're done sizing the battery bank, we've got it here at 1,090 amp hours. We're going to go ahead and go on to the solar panels and the charge controller sizing. And for this, the first step takes you into the average sunlight per day that you get in your area. So this is for the United States. It has a bunch of major cities that you can type in. And for us, I'm going to go ahead and type in our original home state and city where we started from. We launched from Columbia, Missouri. And this gives you about 3.2 hours of sunlight on average per day. Now, to give you a generalized idea of different areas of the world and the United States where you get different amounts of sunlight, you can go ahead and click on this map here, and that will take you through, as you see, the different colors represent different amounts of sunlight per day. So we decided to just enter in an average of about 4 hours per day. And the reason we did that is because we were going to be traveling between the northeast and the southwest of the United States. And as you see in the southwest, it gets anywhere from 5 to 6, and in the northeast it gets anywhere from maybe 1 to 3. So we just decided to average it out at about 4. So if you need to see the different areas and locations and the averages, go ahead and click on that map. But I'm going to go ahead and navigate back to our solar calculator, and I'm going to enter in 4 hours for our, not 34 hours, 4 hours for our average sunlight per day. Now in step 2, it's going to give you the amount of watts that you need based on your total consumption, and the watts of solar panels that you need. So this is about 660 watts of solar panels that you need. And then the last thing you need to know, last couple things you really need to know is how many watts per panel are you going to have. For us, we decided to go with a 150 watt panel, but again, there are a bunch of different options as you can see here. So if we chose 150 watt panels, we would need 5 panels that would give us about 750 watts of energy. Now, that's 750 watts of energy is obviously more than 660 that we currently need, but what it's going to do is it's going to always overcompensate for the number of watts that you need. So if you had maybe, let's say 100 watt panels, you would only need 7 panels for 700 watts because that puts you the closest number that's above 660. So, but for our situation, again, we chose 150 watt panels, and it'll give us 5 panels that will produce 750 watts of power. The last thing you're going to need to know is the solar charge controller sizing. Basically, our solar charge controller needs to be capable of handling about 63 amps of current going between the solar panels and the batteries. So now that you have a good idea of what your system will require, I encourage you to go out and do some more research on what's out there. You may need to make some sacrifices on your end, but if you really want solar power to work for you and your specific needs, that may be the only option that you have. Okay guys, that's going to do it for me. I hope you enjoyed this video on how to properly size your solar system. If you did, make sure to hit that like button down below. Also, let us know what you think in the comment section below. And you guys know the drill. As always, I will see you.